Hello, welcome to Module 1 and Lecture 1 of the course on Environmental Degradation of Materials and Surface Engineering. The topic of today's presentation will be Introduction to Materials and its environment. In this particular talk, with a brief introduction to materials, I will give a brief introduction to environments and subsequently how their interrelations are important for dictating the degradation of materials. Materials may broadly be classified into metals and alloys, ceramics, polymer and composite materials, particularly if you talk about solid state structure materials. Now, metals and alloys may however be classified into ferrous and non-ferrous materials. Similarly, ceramics are crystalline and non-crystalline ceramics, polymeric materials, and composite materials may be of metal matrix composites, ceramic matrix composites or polymer matrix composites. So, all the materials are having a high range of applications as structural materials, but it is very important to know their properties and behavior in order to select them for a particular applications. Now, quickly go to the metallic materials. If you just go to the periodic table, you will find that 90% of the materials are from metals in nature, and these metals are subsequently not used as in nascent form or rather in pure form. They are alloyed with other metals, and but if you just quickly go through the characteristics of the metallic materials, they are nothing but the kind of bond that exists in these metallic materials or by the way they are bonded. So, in metallic materials the nature of bond is metallic in nature, where metal ions are immersed in the sea of electrons, and this is the bonding characteristics which gives it important properties like its high level of reflectivity, then conductivity, and then toughness and hardness. So, because of the kind of bonding that is existing in metallic materials, it is having very unique properties which are not there in ceramic materials or polymeric materials. So, metals are mostly crystalline in nature, and the examples of metals include gold, silver, copper, zinc, tin, and they may be of body centered cubic, sphere centered cubic, hexagonal closed packed, and so on and so forth. Now, if you quickly go to the application of the materials, you will find that it is having a large level of applications in automotive, aerospace as well as construction sectors, transportation sectors, where you will find that environment plays a very important role to determine the service life of this particular component. So, it is important that you know how it interacts with the environment and what would be the ultimate outcome of the environmental metal interactions or environmental alloy interactions, and subsequently how will be the service life of the component. So, this is a case for bridges, which the large bridge is made of metallic materials, which is usually coated by corrosion resistance material, so that it can survive in the environment. Similarly, if you see the aerospace sectors, you will find that in aircraft lot of components are made of the metals and alloys, and particularly aluminum, then titanium based materials are mostly applied for the aircraft applications. Now, if you talk about the another important application of metals and alloys, those are as bioimplant. So, you will find that many implants are made of metals and alloys, like dental implants are made of titanium and its alloys, then cranial plate, then pacemakers, then heart valve cases, bone plates and knee joint, hip joints, those all important implant materials are made of metals and alloys, and where the body environment and its interaction with this metal plays very important role to determine the service life of this implant material. And this is very important applications where if the degradation rate of these materials is very high, then naturally you have to go for resurgery, and which is really very much painful process. So, you have to select the material in such a fashion that it can survive in this human body environment for a longer duration. Now, second type of materials is ceramic materials. So, ceramic materials are non-metallic materials and which are the combination of metals and non-metals, and the nature of bonding which exists in ceramic materials are either covalent or ionic in nature. So, examples of these ceramic materials include like sodium chloride, then different types of oxides, cesium chloride, zinc sulphate and fluoride. So, you will find that there are many ceramic materials which are existing, and those ceramic materials may be categorized into glass based ceramics, which may be with the glass based ceramics, or maybe polycrystalline solid ceramics. So, these are crystalline, but these are non crystalline, and you can also have a number of composites like glass based ceramic crystalline fillers or crystalline based glass fillers. So, these composites are having superior properties as compared to that of their base material like glass or maybe crystalline solids, and they are also having lot of applications like the bulletproof jackets made of this particular ceramic materials, and similarly that silicon carbide powders, and they are basically the silicon and carbon are fused to form silicon carbide powders by sintering process, and which is again used for high temperature applications, and from as cutting tools or drills. So, ceramic materials are having durability at a very high temperature, and they are very hard in nature, which is not there for metallic materials, and which are very strong, and strength wise ceramic materials are harder than that of metallic materials, but they are not really ductile, they are very much brittle in nature. This is silicon nitride turbine rotor made of ceramic materials, then F-16 Fighting Falcon F-100 engine exhaust nozzles. This is made of ceramic materials because of its durability at a very high temperature. They are highly durable in nature. So, they are usually made of these things, ceramic materials. Similarly, glass ceramics are having lot of applications in construction sectors like high strength, aesthetic, low cost, appealing aesthetic, low thermal conductivity, so coefficient of thermal expansion like kitchenwares, then electronic applications, then they are also having for dental replacement purpose, orthodontic application, and high thermal stability, radar wave, low temperature, radar wave transference because of their low coefficient of thermal expansion. So, because of their very important few properties, ceramic materials are also having lot of applications in structural sectors. And finally, polymeric materials are important molecules of high molecular weight. They are made of large numbers of monomers, and they are held together by simple primary bond or secondary like covalent bond, or secondary bonds like hydrogen bonds or van der Waals bond like polyethylene. So, these polymeric materials are also lot of applications because of their light weight, they are very low density, like this is a kind of examples of application of polymeric materials in car body. So, to reduce the weight of the car body, so there are many parts which are made of polymeric materials, and the polymeric materials are very much stable at room temperature and also little bit higher temperature, but they are not stable at a very high temperature, and their density is very low. So, if you just quickly go through the choice of materials, you will find that you have to think of the specific strength. So, higher the specific strength, superior the quality of the material. So, if you just quickly go through the density of different types of materials, you will find that density wise metals and alloys are having highest density, then ceramics, then polymers, and then composites. So, composites is another kind of material which is nothing but the combinations of base materials and the other filler, like it may be metal ceramic combinations or maybe metal polymer compositions, metal polymer blending, like these are basically mixture in order to improve the quality of or in order to improve the properties of the base metal. Like in aluminum as a metal, if you go on adding silicon carbide ceramics, you can increase the strength to a larger extent. Similarly, wear resistance is also increased. On the other hand, if you just go on adding like rubber, you go on adding very fine glass fibers in the in rubber, you will find that the strength of rubber increases. Similarly, you can also add it in polymer, their strength increases. So, like that you can have a combinations of metal and ceramics, metal and polymers, or the ceramics and metals, polymer and ceramics, and finally get the required properties of the overall materials which you are going to design or develop. So, it is very much important categories of materials, and where a lot of focuses are going on. Some of the materials are naturally composites in nature, like wood is a natural composite, but otherwise also you can develop the composite, and you can predict the properties of the composites by knowing the properties of the individual materials, individual constituents which are used to develop the composites. So, as I was mentioning that it is very important to know the tensile strength and density or maybe specific strength, which is nothing but the ratio of strength to density, strength to weight, which basically determines the overall performance of the material. So, if you just quickly go to the tensile strength, again you will find that metallic materials are having more or less higher tensile strength. Ceramics are also having high tensile strength, but their yield strength is higher than that of metals and alloys. Polymeric material are having very low tensile strength, and composites can have near equivalent or higher tensile strength than that of metal, ceramics or polymers, based on the kind of constituents or constituent elements that are used to develop the composite materials. Similarly, if you quickly go through the fracture toughness, you will find that fracture toughness wise metals and alloys, they are basically having highest fracture toughness, and because of their nature of bonding, and then ceramics are having very low fracture toughness, then polymer, and then composite materials are having in between. If you see the electrical and thermal conductivity, metals and alloys are having highest electrical and thermal conductivity, and as a result of which you will find that metals like coppers are very much in use as heat exchangers. Similarly, they are also copper and alloys are also used as electrical wear. Ceramic materials are having very low thermal conductivity. So, as a result of which it is also having some applications where you do not need electrical conductivity, like insulating material, particularly for thermal insulating material, they are very much used as thermal barrier coating. Similarly, polymeric materials are also having not good electrical conductivity, but some high conductivity polymers are also coming up, which are used as coating, and semiconductors are like special categories of materials which are made of metalloids, and they are basically made conductive by special change in the environment, or by application of the dopant, or by application of potential. So, these are the different types of materials in practice, and for the choice of material, it is very important that you should know the specific strength you are looking for, the kind of environment where it has to be used, and finally the desired lifetime which you are looking for. So, based on that you design the component and choose the proper material, and then finally keep it in service. But in service condition, how it will work, it depends on the environmental parameters as well. So, it is very important to know the environment where you are using the component. Particularly, it is also very important that where, for example, you design a car to be used in somewhere in European country in very cold condition, which if you would like to use in summer condition in India, you will find that the lifetime may not be same as that of the same as was designed in cold winter, designed for the cold winter. So, it is very important that you design the component based on the environment where you are using the materials and where you are expected to use the material. So, and the environmental parameters which are existing over there. Now, coming to the next term, that is environment. So, environment is very important, as I mentioned you that performance of any component or materials is very much dependent on the environment. So, as a result of which metal environment interaction is also very important. So, environment comes from the word environer, and which is nothing but, which means surrounding. So, it is nothing but the air, water, land and interrelationships that exist surrounding the living organism, matters or materials or human. So, naturally you have to know what kind of species are there in the environment, how they are interacting with each other, and subsequently this basically ultimately determines your overall I mean you can say service life or your survival chance rather you can say. So, if you quickly go through the components of the environment, so you will find that there are 4 important components of the environment, like atmosphere, which is nothing but a gas which is that which you call is as environment. Lithosphere is solid component in the environment. Hydrosphere is liquid component of the environment, and biosphere is nothing but the zone where the living organism exists. So, these are 4 important components of the environment. So, whenever you think of the environment, so you have to basically specify all the things very carefully, so that you know the complete parameters of the environment. Now, if you just quickly go through the role of environment on materials degradation, you will see that there are 3 important factors which basically dictates the degradation of the materials in the environment. First one is meteorological and climate factors. Second one is the species which are there in air, water and soil, that is which is there in lithosphere and that is atmosphere, and also like these, like it may be normal species which is there like air, it may be some airborne viruses, or it may be some airborne chemicals. So, whatever species are there in the environment, it determines the kind of degradation rate, or how they interact with the component, and finally the micro and macro organisms which are present in the environment. So, these are the 3 important factors which equally determine the degradation behavior of the materials in the environment. So, if you quickly go through the meteorology and climate parameter, it is nothing but like solar irradiation. So, it may be that because of solar irradiation overall environmental temperature changes, humidity content changes. So, if it is highly sunny weather, you will find that which is very near to the solar system, you will find that the temperature is very high. Somewhere the ozone layer is very low, naturally you will find that temperature is also quite high, and it is also not so I mean it may be little harmful. Somewhere where weather is very cloudy, you will see that there may be some humidity, water containing species in the environment. If it is rainy season, lot of water is there in the environment. So, humidity content changes with the temperature of the environment and also the water level in the environment. So, moisture content and temperature, they are very much determined by the solar irradiation and where you are, and these all things are very important. They combiningly determine the interaction with the interaction behavior of the component with the environment. For example, somewhere the weather is highly windy. So, if it is very windy, for example, you will see that lot of hard dust species are carried along with the air, and they can cause typical mechanical degradation of the material by the method, it is may be termed as erosion. So, this is another kind of degradation. So, you will find that in environment, if you see the climate, it is the temperature, which is the humidity content, this is the air, that is rate of the movement of the, or maybe the you can say the speed of the this wind. So, these all things play important role to determine the meteorology and climate, and hence subsequently the degradation behavior of the material. Similarly, if you see the airborne species, it may be typical CO2 is maybe nitrogen, or maybe the combinations of carbon dioxide, nitrogen dioxide, methane. So, many species may be there in that particular air, and sometimes if it is near to mining, there may be some metallic species in metallic or that some that particular minerals may be there in the soil, and that minerals may get absorbed by the typical tree, and then it can also be there in the tree, and also you find that minerals also may be born in the air. So, depending on the zone where you are just using the materials, there the environmental condition changes very frequently, you can say. So, it varies from zone to zone. So, it is very important that you know where the component is used or where is the final application of the component. So, if you just quickly go through the micro and macroorganisms, this is nothing but bacteria, fungi and protozoa. So, these are also the biological species also can cause lot of degradations which are even not known to us properly. So, like there may be different types of prokaryotic or eukaryotic microorganisms like Coccus, Bacillus, Vibrio, Coccobacillus, Spirillum, then Spirochaete. So, these are different types of microbes which are present, that microorganisms which are present in the environment. Similarly, algae, protozoa, fungus, these are also different eukaryotic microorganisms which are present in the environment. So, these particular species can get deposited on the surface of the materials or component and can cover the surface and can accelerate the degradation, you can say. For example, if the fungi is there on the food, naturally it poisons the food, and if it is sometimes you will find that you just keep the component made of copper or maybe brass somewhere, you will find that on top of that there is if it is near to soil, you will find that there are a lot of fungi which are getting deposited on the surface, and if it is deposited for a longer time, not only the deposition of fungus, it can also lead to it can lead to accelerate the chemical degradation of the material, because if the water molecules are there in the environment, the water molecules can also go on just transporting through the fungi layer near to the surface, and there is always differential aeration cell formation, and as a result of which you will find that corrosion process also proceeds in a faster fashion. Those things will be discussed in the later stage, but what I wanted to say is that this microorganism as these are very detrimental to human body, but these are also detrimental to materials, because not directly, because if they directly deposit on the surface of the metal, you can go on cleaning it and then get the metal, but whatever may be, it will deteriorate the physical properties, like luster of the surface changes, it won't be lustrous, but also it can lead to further degradation or accelerate the chemical degradation of the materials. So, finally, what is important here is that if you just quickly go through the degradation of the materials, it will there are many causes which can lead to degradation of the materials because of the presence of different species in the environment. So, finally, the materials factors which basically dictates the degradation behavior, their composition of the materials, the processing steps which are followed for just development of the component, the heat treatment schedule that is followed, then certainly the microstructure of the component, and then thermodynamics of the interaction of the materials with the environment, and naturally the different environmental variables, which is final factor which determines the degradation behavior of the materials. So, in summary, it may be stated that in this particular talk, the different classification of materials are given, and particularly metals are stated about, but naturally if you talk about the metallic materials are not used in pure state, mostly these are used in the state of alloy. So, alloys are nothing but solid solution of another metal in the parent metal, like copper is the pure metal and then brass is the alloy. So, where zinc is added in copper in order to increase the strength of copper. Similarly, if you talk about gold, you will find that gold is never used to develop or to just fabricate or to prepare the jewelry. You will find some amount of copper is added, so that its strength is increased. So, metals in pure state is not used usually. So, for different purposes, different types of alloys are used. For example, steel is an alloy of iron and carbon. When it is plain carbon steel, only carbon is there. Pure iron is of no use because it is having very poor strength, but whenever you are adding carbon, you are increasing the strength. So, it is called alloy. So, whenever you just think of the plain carbon steel, it is having, again, though it is having high strength, but it is not really having very high strength. So, if you are interested to increase the other properties like strength further, there is ultra high strength steel where microalloyed elements are added in steel. Similarly, if you are interested to increase the corrosion resistance property, you have to add chromium in steel, that is called stainless steel. So, those are basically alloys. So, metals and alloys are very important categories of materials, structural materials, which are used as for larger components, which are having very high strength, very high specific strength, very high toughness. And then ceramics. Ceramics are very important material which are also having structural applications, but they are not really so tough as metallic materials are, neither they are having very good ductility. So, they are fabricated in by one step processing usually, and polymeric materials are having very low strength. They are also used where the lightweight is required. Each material is having its characteristics and areas of applications, and naturally different components of environment exist, and the factors responsible for different environmental degradations are also discussed in this particular talk. And these are the references which were followed for the preparation of the lecture for this particular talk, and thank you so much.